Okay, welcome back. Now we're going to run through an SPSS example of dependent samples t-test. Now there are, of course, other data analysis software packages. There are some that are free that require a little more programming expertise than SPSS, and there are some other for purchase programs. SPSS is the program I learned on in my graduate program, and I've just kind of stuck with it over the years, but you could certainly do this. Some people are even so proficient with Excel that they do a lot of this with Excel, but it's just not something I'm that familiar with, so I always look to SPSS. This data set comes from a dissertation student that I had a few years back who was providing an intervention to students who had been diagnosed with ADHD and dyslexia. She had two groups, a treatment and a comparison, or a treatment and a delayed treatment. But she measured them on many outcomes, pre to post. And we are only looking at one of her outcomes. So the C-top, which you can see here, is a reading assessment. And this part of the C-top is for phonological awareness. That's what the PA stands for. Part of her treatment, she hoped, would increase phonological awareness among participants. So for the dependent samples t-test, we're just looking at pre-test scores compared to post-test scores, and we want to see the change pre-test to post-test. Okay, so for the dependent samples t-test, we're going to go to Analyze, and we're still comparing means, right? We are still looking, just like the PowerPoint said, we're not comparing. Our null this time doesn't say our mean doesn't differ from the population mean. What it's saying now is there are no differences pre to post test. So if I take all the pre-test and I subtract all the post-test, the difference should be 0. That is what our null is telling us. There's no difference. So if I look at compare means, I'm going to scroll down here to my, oh, look what SPSS does again, right? So they changed the name on us, paired samples t-test, and that is another name that you'll hear for dependent samples t-test. So just as an EDD person, a person with his or her doctorate, you'll just have to know that what it is still. So it's a paired samples t-test. I'm going to click on it. Now it's asking us, okay, well, what variables do you want to pair? Well, I want to pair pre and post test. So you can click them both over at the same time, or you can click them over one at a time. It doesn't matter. But that's the pair I care about. Now you can ignore this second line that pops up, because what it's doing is just saying, oh, do you have another pair? And in this case, we don't have another pair. So let me check out our options. This, leaving it at the default, is great. So I'm just going to say cancel. We're not talking about Bootstrap at this moment. So let's click OK. All right, so we have our number of obsession-related thoughts. Now, what I want to point out to you is that the mean here, uh-oh, I'm looking at the wrong output. Hold on, that's not right. Doobie-doobie-doo. Let's see. Oh, it's down below. Goodness gracious, I was thinking, no, that doesn't look right. Here we go. There we go. Thank you. See, it's like real life. It's like you're really in class. Okay, here we go. We have our pre-test mean, which is 90.44, and our post-test mean, which is 101. We had 50 participants, and our standard deviation was a little less on the pre-test, a little bit greater on the post-test. All right, so again, our null hypothesis says our pre-test mean is the same as our post-test mean. Right? So because I have a brain, I could see that the pre-test mean is actually different from the post-test mean, right? So what the dependent samples t-test is going to say to us is, yes, but is that mean statistically significantly different? Okay, or what's the likelihood we would have obtained this mean difference if the null is true, right? It's not actually saying the mean is in fact, or the mean difference is in fact 0. It's saying what's the likelihood we would have gotten this mean difference if the null is true. All right, so let's continue. We are going to not look at the paired samples correlation right now. We're going to move on down. Here is our first pair and our only pair. So pre to post, you can see that the mean difference is here. So we have a negative 10.74, or you can think of it in absolute value, right? Because we don't really care which one comes first. We just want to know the difference between those two. The standard deviation of that mean difference is 14.59. We have the standard error of the mean. So if we were doing it by hand, we could plug that in. The confidence interval, which we are going to come back to, it is a confidence interval around the mean difference. There's our t value, or our t calculated, our degrees of freedom, which we know we're going to include in our write-up, and our significance. Okay, so we're looking and we're wondering, is this significance value small enough to declare the statistically significant difference in the pre-test to post-test. All right, so remember, I'm going to click us back over here. Oh, and we need to fill out our table. But I want to take a second and just, if I can get my, hold on, let me get my little board to come back on. I want to, come on, there you are. Okay, I want to just draw that out really quickly if I can. So this is when in class I would go to the whiteboard and start drawing, right? Okay, so remember what's happening behind the scenes, because again, I don't want you to just know what to point and click. I really want you to understand what's happening. So remember, you're envisioning this axis as kind of having a dual purpose. It does have our t values on it, but it also has our probability values on it. Okay, and so here we have 1, 2, 3. Remember that we said that captures most everybody. 1, 2, 3 in the negative direction. And so if I'm looking, I'm going to grab my output again if I can. The t is negative 5.2. Ooh, 5.2, holy cow. All right, and that's in the negative direction. So 3, 4, 5, so like right here. So t equals negative 5.2. And that t value corresponds to a p-value of 0.000, right? Because again, this line is giving us, this axis is giving us t-values, but for every t-value, there's a corresponding p-value, okay? So for every t-value, we know what's the probability of obtaining that t-value, okay? So for this negative 5.2, the p-value is 0.000. Well, when we started, I don't think we set it, which we should have. So let me write our null really quickly. It says that pre to post equals 0, right? There's no difference pre to post. And then the alternative, if you wanted to set it, could say pre to post does not equal 0. All right, and then our alpha level, which we should have said first, yeah, I did it right the first time, is 0.05. All right, that's our cutoff value. That's our p critical, or our alpha, or our risk of type 1 error. However, remember we looked at that list and it had 3, 4, 5 names that it could be, but our alpha level or our cutoff value is 0.05. So if that alpha level is 0.05, and this is -1, -2, the 0.05 level is going to be somewhere right here. Now, I'm just going to draw a little arrow down here because I can't really fit it in, but this probability of 0.05 is right about there. So I'm looking to see, is my obtained probability further out in the tail than my cutoff value, right? And the answer is yes, it is less than 0.05. So what it's saying is the probability I would have obtained the mean difference I got. And remember the mean difference, let me see if I can click back over and get that. Remember we saw the mean difference, here it is. It's this negative 10.74. And so it's saying that the mean difference, the probability I would have gotten that mean difference of, let's just say negative 10. So let me write that. The mean, let's call this diff. How about that? The mean difference of negative 10 approximately. So the probability I would have gotten this mean difference of about negative 10, if the null is true, here it is really, really tiny, 0.000. In fact, it's so tiny, it's beyond our threshold, beyond our cutoff value. Therefore, we're going to declare or say we have statistical significance. Okay? Does that make sense? All right. And so you could, and you might see it written something like results indicate or indicated a statistically significant finding. And then remember you could do your T, and then I'll go grab that degrees of freedom equals the negative 5.2. And then you could say P equals 0.000, or you could say P was less than 0.0 or less than 0.05. Either way is correct. You can report the actual probability, and then your reader can judge for themselves, oh yeah, that's less than 0.05. Or you could just say, I'm not going to tell you exactly what it is, but it is less than 0.05, and you can just put that there, okay? And then you would have a period after whichever one of those you decided to go with. All right, let me flip back over here and get this degrees of freedom, because I don't remember what that sample size was. Let's see. It was 50, so I know it's going to be my sample size minus 1, which is, yep, it's 49. So it would be, I could put my 49 in here. And remember, we include all this information. It's almost like we're verifying ourselves to the reader. So we're not just saying, oh yeah, those were statistically significant. That was a statistically significant result. We're not just saying that. We're giving the reader enough information so that if they wanted to, they could go look up the T, this value right here, the T critical at the 0.05 level, and they could determine for themselves, is it further out in the tail than my negative 5.2? They could, judge that for themselves. Okay, so I think the last thing I need to do is come back up here to my table and add this to our list, because I did not do that before. Let me turn that off. Okay, so this is the dependent samples t-test. All right, and so let's think of how could we say that. So we don't have one sample comparing it to the population this time, do we? We have, so we could say something like this test is used in pre-post situations. We have a group of participants, or we have a group of participants, and we want to examine their performance on some characteristic in a pre to post manner, or something like, does my group's performance change over time? Something like that. Okay? Now, what you can also do, and what we sometimes do in class, is we'll add a third column and it'll be a research example. So I'll go around the class and I'll ask for examples, and they'll give me more of a real life example of when they could potentially see themselves using this Z-test. So if I have, say, a private school administrator, maybe, say for the single sample t-test, maybe they want to compare some result from their private school with a charter school or another private school, a competition school, or something like that, where it's more of, maybe a private school has a database where it looks at all private schools in the U.S. or something like that. Or I know there's information on, say, all Catholic schools in the U.S. Maybe they want to compare their school's result to the national average for Catholic schools or something like that. So in other words, just a research scenario that would help them remember when to use this test. Okay? All right, so in our next video, we will tackle our last t-test, and that is going to be the independent samples t-test.